Hi, we're Flora, sourcing critical metals from plants. Humanity has an insatiable demand for critical metals, metals like rare earth elements, nickel, cobalt, and copper, and that means that we need a new source of critical metals now. At Rare Flora, we're building plants that can mine metals in mine tailings and low-grade ore. Plants are fast to deploy with low startup costs, so we can create a domestic supply without foreign dependencies. Phytomining extends the lifespan of existing mines by extracting additional value, strengthening supply chains, and reducing resource disruptions. It happens in three steps. First is accumulation. Plants are farmed and the metals are taken in through the roots. Next is separation. Metals are separated based on their valence within the plant tissues. And then the final step is recovery. Here, the metal is recovered from the plant and can be used as a drop-in addition to ore refining and integrated into existing manufacturing supply chains. We make money by selling the metals as a bioconcentrate from the plants. Rare Flora has been working on this technology for the last 5 years. It started with the sequencing of the first hyperaccumulator genome in 2013 that enabled molecular insights into metal accumulation. During my PhD, I discovered genes promoting growth in hyperaccumulator plants, which opened new avenues to understanding and enhancing metal uptake. In 2021, we combined computational and plant biology expertise to improve metal-based mining and remediation. And today, Tony and I are scaling from research to field trials, seeking collaborations for funding and expansion. We're harnessing plant biotechnology to revolutionize plant-based mining on marginal lands. This platform allows us to unlock a suite of licensable IPs. We are leading two commercial products, a gene-edited plant and a biostimulant peptide for soil and roots, both designed to enhance metal uptake into plant tissues. We're also partnering with NREL in Colorado on new acid digestion methods that use fewer chemicals and are more practical for extracting metals from the plant biomass. There are a number of alternative technical approaches, all to combat open pit mining, which is being depleted and has long development timelines. We focus on accessing waste ore, tailings, and metal-rich soils, which offer lower concentrations but are significantly more cost-effective to mine. With our technology, compared to very extreme sources like deep-sea mining or brine extraction, we can recover tremendous amounts of rare earth elements. We're not alone in being a phytomining company. In recent years, there's been a number of them that have come online, but they mostly have focused on this legacy plant that takes up nickel and is not always in the US. Rare Flora is the only one currently focused on rare earth elements and is expanding to other metals as we scale. Phytomining has the potential to be a huge game changer in the US. Right now, the US barely registers in global rare earth element production, with only a $70 million market compared to China, which dominates the industry due to cheaper labor and lower production costs. However, with phytomining, we can unlock significant domestic supply and increase the rare earth element market in the US by 40%, making us a real competitor. As we grow, we plan to include phytomining plants that can take up nickel, cobalt, and copper, making this a $348 billion market. We took the opportunity to go to conferences earlier this year through SDSU's NSF I-Corps program, where we validated the demand for this business model by going to talk directly to buyers like refining and manufacturing partners who are currently offering 40 to 60% payout for rare earth element concentrates. We learned that New U.S. refineries need domestic rare earth element sources, or they'll keep relying on China. U.S. rare earths is one of them. They're already buying from China and they're really excited about a homegrown supply of critical metals. Our ability to use plants as an additional source of critical metals will enable leading manufacturers to create identical and more sustainable versions of what they're already doing, which means more energy, defense, and electronics made domestically in the US. As we scale, we already are launching our first pilot trial in Winchester down in Southern California. We've demonstrated the entire process flow with an extensive techno-economic analysis, and we've evaluated both post-harvest processing and biomass handling methods. This is our current team. I have expertise in plant biology and did my PhD at Stanford. And when I went to the Salk Institute, I met my co-founder, Tony, who is a computational bioinformatician that worked with me on sequencing new plant genomes and comparative genomics, which we now leverage here at Flora. We have a really great uh, number of advisors who will help us on the metallurgy side as well as the business and commercial aspects of our company. We're excited to collaborate and make phytomining a reality. Thanks so much.